Thanks for joining us today as we walk through bringing your custom Python model to Nextmove. I'm Renuka Goff on the product marketing side here at Nextmove, and I'll be your host for today. Joining me is our presenter, Nicole Misek, our VP of Engineering. On the right, we have a quick agenda for today. We will do a very quick orientation to Nextmove and our Python SDK. And then Nicole will dive right into deploying, running, and testing your custom Python model on Nextmove. We will, of course, save some time at the end for Q&A, so feel free to use the chat feature in Zoom and just make sure to toggle between everyone and host and panelists, depending on who you want your message to go to. And of course, feel free to use the Q&A feature as well. So with that, let's dive right in. So for those folks who are new and joining us for the first time, Nextmove is a decision science platform. And with this platform, we accelerate teams with a few things. We have decision ops tooling, including a testing framework and simple deployment. We have optimization integrations with popular modeling tools and solvers, including Garobi, OR tools, Ample, Highs, and more. And we have decision app quick starts as well. So as the name implies, those apps allow you to get started easily and quickly with pre-built models for common use cases that we see like routing and scheduling. So we've built this platform so teams can focus on modeling and not on building and maintaining decision ops tooling. You can mix and match your favorite solvers. You don't have to just pick one for all of your use cases. And it's all in one place, so you can focus on safely scaling your optimization projects. And we'll focus for just a moment on the concept of decision ops and the core themes. The first step is collaboration. And we found that teams move a lot faster when they're able to easily and transparently work within their own teams and across other teams in the organization. So we make it really easy to set up those teams in your Nextmove account and define roles for safely collaborating. And then in order to move quickly and safely, testing is a critical step in the workflow. So we offer a testing framework for tests like batch tests, for simulating multiple what-if scenarios, switchback testing with production data, and more. So there's a safe path to deployment. And to make that path more repeatable, we think about versioning and CI/CD for decision models as the same process used for any other software. So updating and making model improvements can happen in that same way, and it's very streamlined. So of course, throughout that process, model transparency is key. So you can create a system of record for your model and easily understand when model changes were made, if there were errors, and kind of any other specific details of your model and its run. And you can access your decision model with an API to create a decision service. And that service works with your current system, so you don't have to worry about how everything all fits together. And of course, you can easily deploy to production grade scalable infrastructure, so your testing can happen in the same environment as your production run. Today, we'll focus on operationalizing your decision model. So really making crossing the divide from development to production smoother and safer. So Nicole, I'll hand it over to you to show folks how to safely get across that canyon there.
Thanks, Renu. So before we dive into our Python SDK, I just want to call out that everything you'll be looking at today with respect to that SDK is completely optional. If you already have your own custom model that's pre-built that you're happy with, there's no need to refactor it to use our Python SDK. So to bring your model to Nextmove, there are just a few basic requirements that must be met to run on the Nextmove platform. And most of those your model probably already does, with the exception of a couple of them. So starting out, your model needs to read input from a file or standard in, which it likely already does. It needs to write a solution to a file or standard out, which again, it likely already does. One thing that's sort of a mixed bag is that logs need to be printed to standard error instead of standard out. And we surface anything that's printed to standard error as a log on the Nextmove platform. And then the last two are net new that you would need to add in order to migrate to the platform. So the first is writing statistics to standard out. according to our statistics convention. So we have this convention, which you can see on the right in that Nextmv output construct. If you conform to our statistics convention, we automatically parse those statistics and we show them on your runs. We also pull them out for summarizing experiment results. So that's just a really helpful piece to add to your models to kind of make full use of the platform. And then the other piece that's net new would be including an app manifest in the root of your project. And this is what tells the Nextmv cloud what runtime to run the model on and what requirements it needs to be able to run on the Nextmv cloud. So we've worked a lot with decision model practitioners, and we've thought a lot about the experience of working with decision models. And from what we've seen, there has been this common pattern for building decision models, and that's what we're trying to formalize with the Nextmv Python SDK. So some of these may seem obvious to you, but in practice, there are a lot of repeated steps, repeated blocks of code that really could be simplified. And so that is the fundamental purpose of the Nextmv Python SDK. So what we've found is that there are these 4 minimum steps for constructing a decision model. The first is consuming an input from source. Next is consuming options. Some might refer to these as parameters or constants. And then the third is using that input, those options, and some technology like a solver, heuristics, whatever you choose to get to a solution. And then lastly, you want to characterize that solution with some statistics. So the core idea we're trying to achieve with the Python SDK is formalizing these 4 steps with APIs to support each of them. All right, so now it's time for a speed run. I'm going to quickly share the Nextmv console to orient us before I dive into the code. All right, so what you're seeing here is our marketplace section in the Nextmv console. This is a really helpful place for launching off either into a custom application, or you might just use these apps directly for a low-code experience. So there are varying levels of complexity, with our featured app, Nextmv Routing, being a really, really comprehensive engine for routing, covers 99% of routing use cases. And we have many users that can subscribe to this app and use it as is without any level of customization. We also have offerings in shift scheduling, shift assignment, order fulfillment that are really great. And we also have some kind of starter templates or toy problems that are solving knapsack. And those are really good launching off points if you want to sort of customize an assignment algorithm or something. So today I'm going to be focusing on the Pyomo shift assignment application. And you can see that this available constraints kind of summarizes the schema of this app. So we have available workers, available shifts, and we're trying to assign those workers to those shifts. Workers have availability. There are requirements around having a minimum rest time between shifts. Workers and shifts have qualifications. Workers have preferences, and there's start and end times of the shifts and requirements for the number of workers to meet the shift requirements. So that's kind of a high-level view of that application. And now I will show you what I did to customize this application. So I clicked on that GitHub link. It took me here to our community apps repo. And what I did was I cloned this Python Pyomo shift assignment application so that I could get it on my local file system. And I made some customizations to it. And so I'm going to jump into my apps and kind of show you the end state of that customization before we dive deeper into the code and how I got there. So I'm going to jump into Tech Talk 1016, which is the app where I pushed up my custom code for the shift assignment problem. You can see I pushed it up this morning at 10:01 Eastern time. And so now I'm going to show you, you can see here, this is the API reference for that application. So anything that I'm showing you today in the console can be done programmatically. And now I'll jump into my run history. So you can see here, this is a log of all of my past runs, and I can click into my most recent one. And what you're seeing here is on the details page, we present metadata about that run. So what instance did it run on? What was the status? Did it succeed? Did it fail? Or is it currently running? How long it took, and input and output size, and so on. Also, you can see the statistics on the right. So these statistics are what I surfaced using the Nextmv Python SDK in my custom code. And so anything that you're seeing as custom, these are net new statistics or KPIs that are important to me that I surfaced through my custom decision model. And we'll go through how I added one of these, for example, this utilization metric. Now, if you go into input, you can always get the input that corresponds to the result that you got. So if you go back, to last week's runs, you can always replicate the result that you got using that input. You can download it if you'd like, and you can see here we have our workers and our rules and our shifts. Then we move into result, and this was the solution to this particular run against that input that I just showed. You can see here that we have workers assigned to their respective shifts. And now if we look in logs, we can see this is what I surfaced with the Nextmv Python SDK. And so I printed some kind of high-level summary of the input data. This was a simple example with 4 shifts and 5 workers. And I also printed a kind of short-term debugging. I was printing out the objective value here. So this just shows that you can kind of print whatever you want in the logs, and it's just helpful for either debugging or for understanding where you are in the process, because we also have these live logs. And so often for long running jobs, we'll have, interim print statements in here to give us some insight into where we are in the execution. So that's run history. And now I'm going to skip down to experiments. So we have a suite of testing methodologies here, ranging from historical tests like scenario testing, batch, and acceptance testing. We also have tests on production traffic like shadow testing and switchback testing. I'm going to focus on scenario testing for today, and I can give you a sense for what it's like to create a new scenario test. So since this is Pyomo, let's say I want to explore different solvers. I can either upload files, or I can pick from an existing input set, which I will do for demo purposes. I can select the instance. So this is the version of my executable plus any default configuration that I had on it. And now I can set some configuration on this particular scenario test. So let's say I want to explore all the providers, all the open source providers like CBC, GLPK, Skip. Let's say I also want to explore duration. So let's say 10, 20, 30 seconds. You can see here on the right that these configurations kind of blew up into all the permutations of each of these 2 option sets. So that's really helpful because we just figure that out for you. We spawn out and we say, okay, there's going to be 18 runs coming out of this. And also we can add repetitions. So if the underlying model is non-deterministic for whatever reason, you can, run with, 10 or 30 repetitions, whatever you choose. So you can fire that off, then you can review your runs, and you can, say, okay, well, I actually don't want, this particular combination to execute. So I can kind of deselect some of those runs. And so that's a really helpful feature as well. I'm going to go ahead and cancel this because I actually already have an experiment that we can take a look at. So this is a past scenario test that I ran. And you can see here that you get this interactive pivot table. And so I can pull out option set and scenario ID, for example, and I can just have a look at the different solvers and what their objective value was. And this is kind of a simple example where everything was the same because of the size of the inputs and the complexity of the model. So I was able to get to the same solution with all of those open source solvers. Now I can select on this drop down, and I can select any of those custom KPIs or custom statistics that I surfaced with the Nextmv Python SDK. For example, utilization is a new metric that I added in my custom code. And that automatically gets picked up here for purposes of rendering the pivot table, and you can view the comparison in the pivot table. And again, this is a not super exciting finding because everything is exactly the same for utilization. We can see a little bit of difference in run duration, but again, it's negligible. GLPK and skip runs ever so slightly faster than CBC to get to that solution. Likely, if we had a bigger problem, more complex constraints, and we pulled Gurobi in here, for example, we might start seeing, some differences as the problem scales up. The purpose of today is really to just show you kind of how the mechanics work of wiring up the custom statistics and how that gets surfaced in scenario testing. All right, so I am going to jump over to VS Code now, and I can show you kind of how we got here. Okay, so what you're seeing here is that Pyomo shift assignment model on my local file system. And this, again, was just, I got this from cloning that repository and pulling out this particular decision model. And so what you're seeing is this sample JSON came with that repository. Again, we have workers, which have IDs, qualifications, rules, preferences, and availabilities. In this case, we have one rule, which is there must be 11 hours of rest time between shifts. And our shifts have IDs, start and end times, qualifications for who can serve that shift, and a required count of workers needed to fill that shift. So now I'm going to jump into the app manifest. So this is what I mentioned earlier is one of the net new things that you'll just need to add to your model for it to run on the Nextmv platform. And again, this tells the Nextmv cloud where to run the decision model and the requirements that it needs to run. And so in this case, we're saying this is a Python application versus a Go or Java, for example, app. We're also specifying that this is running on the Pyomo runtime, and that runtime has pre-installed all of the solvers that we need for Pyomo. And under files, this specifies the files that you want to bundle up when you use our clients to push the decision model up into the Nextmv cloud. So if you have your code split across multiple Python files, you would just enumerate those here. And then lastly, we have this Python pip requirements section where you can pass in your requirements.txt. And this just makes sure that all of those pip requirements are packaged up and bundled as part of the push up to the Nextmv cloud so that you can have a consistent experience that you're having locally on the Nextmv cloud. So now we can jump into the main function. And really what we want to talk about today is kind of how we use that Python SDK to get to what I showed you in the Nextmv console. So starting out, we can see in our main function that we have options. So options was one of those steps that we talked about. It's a common pattern for decision models is exposing command line options for you to configure your model for production runs. And so Nextmv options are composed of Nextmv parameters. And when you expose your options this way, what it does is it allows you to configure these options on the console the way that I showed you earlier on the call. You can also send these options on an individual run. And these work both for running locally through the CLI or Python or as environment variables. And we can add whatever we want here to make our model do what it needs to do by configuring it. So for example, we can add a config that ignores the qualifications constraint for shift assignment. So we can say, we don't care if workers are qualified, we're just gonna assign them if they're available. So to do that, we can add a Nextmv parameter. We can say ignore qualifications, and that's a bool. We'll default it to false. And so what this does is it immediately surfaces this ignore qualifications config as a Nextmv option. But now we have to wire that up to do something in our logic. So we can have a look at where we add that qualifications constraint in the code. And that's right here. So we can say, if our input options ignore, if not ignoring qualifications, then we can go ahead and apply that that qualifications constraint. So if ignore qualifications is on, then we just will not execute this code block. All right. So that is options. Next, we move on to reading inputs. We have a helper function in the Nextmv Python SDK called load local. And this makes it easier to work with reading input files of varying file types from the file system. This works for running on my local machine as well as running on the Nextmv cloud, so you don't have to adapt the way you read an input depending on your environment. So that's really helpful. And you can also pass in custom options here. And this is really how you wire up those options from above to your input. And you probably saw that when I wired up that ignore qualifications constraint down below, I referenced input.options.ignore qualifications. So that's reading an input, which was one of the other common patterns that we saw. And now we can move on to logging. So right here, you can see that we're printing out a few logs using the log helper function from the SDK. This is a pretty basic one, and that really what this is doing is just redirecting your print statements to standard error, as I mentioned before, because that is anything printed to standard error we interpret as a log. And as I mentioned before, anything that's printed this way will be surfaced in the live logs as well as the historical logs for past runs. And now we move on to the solve function, which is really where the core of your algorithm lives. And so in this case, this algorithm is obviously solving a shift assignment problem. I'm not going to dive into the details of this particular algorithm today, but what I will do is I'm going to scroll down to the end so you can see here the solve function is returning a Nextmv output. The Nextmv output is a helper function which returns the solution output along with the options that were used to generate that particular solution. And you can see we also have statistics to characterize that solution. Now, statistics, if we scroll up a little bit, are defined here using the statistics helper function from the Python SDK. And this helper function is there to just ensure that we're meeting the statistics convention for any of the KPIs that we're printing about this solution. So you can see this custom block is really, you can put whatever you want in here. And so to illustrate that, we can just create a new metric for utilization. And utilization is defined as the active workers divided by the total workers. And we're just handling if total workers is 0 here. So that's how easy it is to surface a new KPI or statistic in your decision model. And if you recall from when I shared the scenario test, this was automatically picked up just by presenting it here in the custom statistics block. All right, so last up here is writing the output. So we have this helper function called write local, and write local returns that output that we just went through. And actually, in the coming months, we'll be adding support for more input sources and output destinations beyond standard out, which is what write.local or write local is doing. For example, we're going to be servicing, integrations with Snowflake and S3 and other sources and destinations. So this will expand soon to kind of have more direct integrations with your production stack. So that is really a summary of kind of how all of these different constructs from the Python SDK can be used to make it easier to build your decision model. And now the next step is really to push this up. And so we use our Python SDK for pushing our local changes from our local file system up to the Nextmv cloud. And the way we do that is by creating a client using our Nextmv API key, which I have stored as an environment variable, and then instantiating the app that we want to push to, and then running an app.push. And so I can do that now. Let me just save my changes. And so I can run Python push.py. And so what this is doing is it's pushing our local code up into the Nextmv cloud environment. And this may not seem like a huge thing, but it really does streamline the modeling and deployment process and allows those decision modelers who prefer to stay in their Python environment, stay there. We also still have the Nextmv CLI, which is always there for those who prefer that experience of deploying their code. But this is a new addition and very nice for Python users. And so we can see here that we've now deployed that customized application to that Tech Talk 1016 app. And then that's kind of how we got to that state of that running the full flow through scenario testing. All right.
Wonderful. Thank you so much for that, Nicole. That was great. I'll just quickly share my screen again here. Okay, so what just happened? Nicole demoed a lot, but I wanted to highlight a few things that were particularly cool. She started with a Python community app in GitHub. So again, we have those community apps so you can get started with the use case and the language and the modeling tool and solvers that you're already using. And then we saw that she created a custom option and statistic using the Python SDK and really demonstrating how easy it is to create those and then surface those for analysis in the Nextmv UI. At the end, we saw she deployed the model to Nextmv from a Python environment. Like she mentioned, really nice for the workflow if you are a Python user and already in that environment and not having to, kind of change context there to deploy. And in case you missed it, she did perform a scenario test using different solvers. Really cool to see, something that's nice to be able to demonstrate how different solvers are performing with your specific problem and being able to look at that through the lens of the custom statistics as well that you've surfaced. So very cool. I will share just a quick kind of zoom out overview of what Nicole showed in her demo just now, some of the different pieces. Starting on the left, you see the model code. Nicole cloned one of our community apps from GitHub. Of course, you can bring your own completely custom decision model. This is what, kind of plugs into your Nextmv account and powers those decision apps. So you can use practices like CI/CD. In the center, we have your Nextmv account. You can use multiple solvers and modeling tools, as we mentioned. You can have a Garobi price optimization app, a high fulfillment app, and so on, each accessible via a REST API. And then an app is really just a container for everything that you need to solve your problem. So obviously that includes the model code on the left, But it also includes on the right, you see information like the run history of your app, a system of record of when the model was updated and by who, as well as the experimentation framework that Nicole demoed as well. Speaking of collaboration and teams with experimentation, you can see on the bottom that we have different roles represented. You can easily create teams and define roles to collaborate safely and effectively. And lastly, at the top, you can see the various ways to interface with your Nextmv account and your decision apps. So we have the modeling SDK. Nicole just demoed the Python SDK. We saw the web UI or our Nextmv console where you can run scenario tests and see all those details of your app. And then, of course, a common API layer for interacting with your decision apps. So that's just a very quick overview of how it all fits together. And I know we are actually over time, but I'd love to squeeze in one question, if that's okay with folks. I'll stop sharing here so we can see our faces. One question I'd love to squeeze in is, can I push my Python model to Nextmv from a notebook?
Yeah, so what I showed today is basically a layer outside of your application, which takes all the files that are part of your decision model and pushes them up to the Nextmove cloud. Uh, we have plans to extend this to more of a cohesive notebook experience, I'll call it. And the idea there is that we want to have a concept of a model in our Python SDK. And once you define the model as a construct, then within your notebook, you'd be able to push up a model versus files. And so that's going to really make the notebook experience seamless. And that's basically next up for us for the Python SDK. So that'll be really exciting.
Yeah, absolutely. Okay, I know I held people over the time allotted here, so I just want to thank everybody for joining us today. If you've asked a question and we didn't get to it, we will absolutely follow up via email, so no worries there. If you thought of other questions, send those over to us. We love chatting about this stuff. As a reminder, you can try everything Nicole just demoed by signing up for a free Nextmove account at nextmv.io. And we really enjoyed having you all today. So thanks again, and we will see you next time.
Bye.